Today in this webinar, we are trying to answer a bunch of questions related to BMS, OTA system, and how we can update the firmware of the BMS. So first we will be like to see the why we are using BMS in the electric vehicle. Then we will be moving forward to the OTA system. Then we will be seeing how we can update the firmware onto any electronic control unit using OTA update. So these questions will make sense to you, which want to make their career in an automotive industry. So first we will be looking at what is BMS. So BMS is just a brain behind the battery packs. You can also say this is a brain of the electric vehicle. First we will be looking at what is BMS. So BMS is just a brain behind the battery packs. And why we are using the BMS? Like BMS constantly monitor the current, temperature, and the voltage of the battery. And why we are using the BMS? Because like automotive industry is a very competitive industry. Like everyone wants to provide their best in this cheapest price possible. So even we can't afford a single extra wire in our vehicle. You might be aware about the CAN. Bosch invented CAN because we don't want to use more and more wires to connect the ECUs. So we have the Bosch has invented CAN. So we can communicate with all ECUs using two wires. So there must be some reason to use battery management system, right? So you got the point, like battery management system is used to monitor the current, temperature and the voltage of the battery. But why we are using BMS in the electric vehicle? We will be looking in this slide. Like because we mostly use lithium ion cells in the battery management in the electric vehicles. So there would be a battery pack which will be having a number of lithium ion cells. And why we are using lithium ion cells? Because density is very good in the lithium ion cells. Okay. So, but the thing is, like lithium ion cells will be having some chemical properties, and they might be having manufactured by some industry, some factories. So there should be, because nothing is ideal in the world. So there would be some chemical properties difference between each cell. Means some of the cells will be having the capacity of 4.5 volt, and some of the cells will be having the capacity of 4.3 volt. So that might be possible. So every cells would not be having a same capacity due to the chemical changes in the properties. And why we are using the BMS? Because if there is a sudden changes in the temperature, so there might be happen, like there might be a hydrogen gas or some of the flammable gas will be inside the battery pack, and battery will explode. And if the battery will explode, the whole electric vehicle go to the disaster. For using the lithium ion cells, we need to check the two critical design issues. Like first, there should be no overcharging for the battery. Like if you will be overcharging the lithium ion cells, you can damage them and cause overheating. And these can be go up to the explosion. Okay. So we can't do the overcharging on the battery. And the second thing would be we can't discharge the battery below a certain threshold, because there might be a certain threshold and we can't discharge any lithium ion cells below that threshold. Okay. So we have to maintain the threshold. Means let us suppose if we are using a lithium phosphorus cells, so that might be the range of, or the threshold would be 2.5 volt to 4 or to 4.5 volt. Okay. So we have to monitor these things. The lithium ion cells would not discharge below 2.5 volt, and it should not overcharge above 4 volt. So for these things, we need to use the battery management system in electric vehicles. And if we will talk about the mobile phones, if we will talk about the laptops, these things also having the lithium ion cells, and battery management system should inside your laptop. That would handle these things, the overcharging and over discharging issues. Okay, because we will be more discussing about the OTA system or the BMS firmware, but before knowing these things, you have to be little bit aware about the what BMS is and what is the functional box of the BMS. Okay, so as I told you, BMS is used to monitor the current, temperature and voltage. So what things we need into the BMS? So we need FET drivers, because there would be so many MOSFETs inside the battery management system that will be using. Let us suppose there is any short circuit into the in electric vehicle or in BMS. So using FET drivers or like the MOSFET on off drivers, we can cut off and the power between the battery packs or the electric control unit or the electronic control units. Okay, and there would be a fuel gauge monitor, means because like if you will be having a fossil fuel vehicle, what will happen, you already aware, like if there is 1 liter of petrol or fossil fuel inside your vehicle, you know, like you can go up to 30 kilometer or 40 kilometer of, because depends on your mileage, you can already measure that. But the main issue inside the electric vehicle is that you need to check, because there is no any sensor in the world right now which can measure the current exact voltage of the each cells when the car is onto the moving condition, because we can't measure the exact coulomb counting or the capacity inside of lithium ion cells, because while we are building a battery pack, they might be having 40 lithium ion cells, 50 lithium ion cells, depends on what voltage and current we require from that battery pack. Okay, so we will be having a cutoff FETs and FET drivers, which will be helping us to cut off the battery pack from the other ECUs. Fuel gauge monitor will be using for checking how much capacity, how much coulombs, how much voltage has been left inside the battery. Okay, so these things we will be measure using fuel gauge monitor. There would be a cell voltage monitor, because as I told you, we can't overcharge and discharge the lithium ion cells, so we need to constantly monitor the voltage, and we need to check whether the voltage is inside the threshold or not. And there would be some voltage balance, because as I told you, you might be using more than 30 and 40 lithium ion cells, so that might be having the possibility, like one cells will be having the capacity of 4.5 volt and another lithium ion cells will be having the capacity of 4.3 volt or 4.4 volt. So there would be a certain difference between the capacity of each cells. So we have to balance the cell voltage using any of the circuit, like we can use active balancing or passive balancing for the same. Okay, there would be a real-time clock, because we will be constantly monitoring these things, so there should be real-time clock inside the BMS circuit, and there should be some sensor which can help us to measure the temperature for the battery pack and also the temperature of the battery management system circuit. These are the functional blocks of the BMS which we need while we are building any battery management system for any of the electric vehicle, or if any of the laptop or any of the lithium ion battery packs. So now we will be moving forward for the BMS firmware. What is the firmware? So firmware is a small piece of software that makes hardware work. Okay, so if you will be seeing any of the embedded system, they will be having some firmware inside the microcontroller flash memory. Okay, like if I will talk about the washing machine or any of the embedded system, mobile phones, there would be some firmware inside your flash memory of the microcontroller, or there would be an external EEPROM or RAM in which you will be having the firmware. Okay, so firmware is a piece of software that makes hardware works and do what its manufacturer intended to do. Okay, so without firmware, most of the electronic devices we use would not be able to work, because if there is no firmware inside the any hardware, so hardware will not know, the processor will not know what instruction they need to follow. Okay, so there should be a firmware inside of any embedded system. So BMS will also be having a firmware which will be knowing as BMS firmware. Okay, so now we will be looking at, let us suppose we are using any microcontroller unit like any ARM Cortex, because you might be familiar of the architecture. There would be an architecture called ARM Cortex series microcontroller, okay, or the microprocessor. The 99% of the embedded device, if you will talk about the mobile phones, if you will talk about the electric vehicles, all will be using the ARM Cortex M series microcontroller. Okay, so in the ARM Cortex M series microcontroller, there would be some flash memory inside the microcontroller unit. They might be having 512 KB, 1 MB of flash. It depends on the microcontroller, which microcontroller you are going to use for your PCB designing or for the BMS. So let us suppose you are having a microcontroller which are having a 512 KB of flash. Okay, so what do you need? Because you need to put a firmware inside the hardware, means inside the microcontroller unit. So there is only three ways you can update the firmware inside a microcontroller unit. There would be one way, you have to connect your board with any of the laptop. You have to use some flash software through which you can flash any of the binary file or SREC file inside the microcontroller. And another way would be you would be having some bootloader. So I will be talking about the bootloader in the next slide, but I'm telling you the information like in bootloader, what is the task of the bootloader? Bootloader helps to write the firmware inside the flash memory, because if you will be having a washing machine, you can't have the OTA system enabled onto the washing machine. If there is any error coming to your washing machine, someone will come and they have to check the microcontroller by checking some hardware by putting some debug software. Okay, so you have to use some hardware to update the firmware. Okay, because I'm just giving you one example. Let us suppose maybe like 7 to 8 years ago, you will be having some Nokia phones. In the Nokia phones, there would be no option of the OTA updates as you have in your Android phone. So that time, how you can update the firmware? You have to connect your mobile phone to your laptop using some cables which will be provided by the Nokia, and you have to use some software which will be provided by the Nokia, and through which you can flash or update your firmware of your mobile phone. But now you don't need to connect your phone with any of the hardware. You just need to connect your phone to the internet, and through which you can update the firmware inside your mobile phone. So in the same manner, you can update the firmware from anywhere in the world in your electric vehicles. So for that you need a bootloader. So what is the task of the bootloader? Bootloader is a short program used to burn the firmware to the microcontroller without any programmer device, either like flash or debugger device. So you don't need any software or any hardware to update the firmware if you have a bootloader inside your microcontroller. Okay, so how these things work, we will be looking forward to. So there is two types of update we can provide for the battery management system. Okay, one would be there would be only one slot for the firmware. Okay, so there is only normal OTA update, just like your mobile phone. Okay, so what you will do in your mobile phone, like if you will check for updates, then mobile phone will download the updates. Okay, from the a server, and after the update they will be, you need to reboot that. So in the same manner, what BMS firmware will do, in the bootloader we will be writing the code like whenever we will be pressing the power on reset button on your microcontroller, then they will be checking whether any new firmware update has come to the server or not. If any firmware update has come, they will be downloading that firmware from the cloud, and after that they will be writing that firmware inside the current firmware. Okay, means they will be overwriting the current firmware to the new firmware. Okay, so in the same you do in your mobile phone. So what will happen, let us suppose you are running Android 7.0 and now you got the update of Android 8.0. So what you will be doing, you will be downloading that, and once you put the reset button or the reboot, then the bootloader will be checking whether there is any new update firmware file inside your SD card or inside your internal memory or not. If there is any update file they found, they will be doing the updation process, and you will be seeing the updation process in your mobile screen. And once the update will finish, they will override the current firmware with new firmware. So that is a normal OTA update. Okay, now we will be talking about the A by B swap OTA update, because the thing is, let's talk about the mobile phone. If you are using a mobile phone and in some error happens in your mobile phone while you are updating the firmware, there is not much issue will happen, right? But if you are driving an electric vehicle and in the same time if any error happen in the firmware, there is some bug in the firmware, so what will happen? Your car will stop working. Okay, then you need to go to the service center, or and because it is possible you may be out of town, so that is a critical condition. So we don't use normal OTA update in the BMS. If we will be talking about advanced BMS, okay, we will be using A by B swap techniques. So what is this technique and why we are using that technique? Because what we are doing is we will be having the current firmware as well as the old firmware. Means let us suppose you got an update from the cloud. There is some update from the company or the vendor side, so you will be writing those firmware onto the other part of the flash memory, so they will be not overwriting the current firmware. And after updating it, there will be, after update you will be seeing there would be a current firmware and new firmware. Okay, so bootloader will redirect the microcontroller to the new firmware. So microcontroller will be executing the new firmware, but let us suppose there is some bug inside the new firmware. There is some coding error, some bugs inside that. So what will happen? They will be redirect to the old firmware or the current firmware. Okay, so this is sometimes it's happen in the Windows updates when you switch from Windows 8 to Windows 10 in the laptop. So if you don't like that, you can also downgrade from Windows 10 to Windows 8. That time Windows given that facility. So in the same manner, we provide the firmware update like that in the BMS system. If there is any error occur into the new firmware, so the microcontroller unit will redirect to the current firmware and they will be working onto the current firmware. So the system will get the notification there is some error into the new firmware. The developer will be looking towards it. They will be finding the bugs and they will be again sending the new firmware from the OTA updates. Okay, and there is also one benefit of A by B swap OTA updates, because see, in the normal OTA update, what will happen at what time you are updating the current firmware from the new firmware, you can't actually use your device, you can't use your electric vehicle at the same time because you are overwriting the current firmware. So there would be no chance, because in the same manner when your mobile phone is updating, at the same time you can't use your mobile phone, you have to wait for 10 to 15 minutes that time, right? But maybe because mobile phone will be having only one processor, but if we will talking about real-time system like autonomous vehicle or electric vehicle, they would be having more than 100 of ECUs. And if you want to update all the ECUs firmware in one time, it might be taking maybe 1 hour, 2 hour, or more than that. Okay, so you can't wait for that. Maybe you want to go somewhere else with electric vehicle and you are waiting to update has to be finished. So this is not a flexible way to update any of the electric vehicle firmware. Okay, so mostly we use A by B swap OT update. So what will happen, because there is some microcontroller, the latest microcontroller has come up in the market in which microcontroller unit will be executing the current firmware, and at the same time bootloader can update the latest firmware. Okay, so there would be two section, means two partition inside the flash memory, one partition for the old firmware, second partition for the new firmware. Okay, so anytime the new firmware will come, the microcontroller unit will be executing the current firmware, but at the same time they will be also putting the firmware inside the new firmware section or the partition. And once the whole update has been written on inside the flash memory, they just change the stack pointer and program counter. Means in the layman language, they will be redirecting the microcontroller from the old firmware to the new firmware. So it will be taking only less time. Means while flashing that whole firmware, new firmware inside the flash memory, you should not wait for that. You just need to wait for maybe 15 to 20 seconds or maybe 1 minute while they will be redirecting from old firmware to the current firmware. Okay, so that is the advantage of A by B swap OT update. Okay,